Good evening, everyone. So it seems very few of us are here. So I'll keep on admitting students, but in the interest of time, we'll start. Okay. So am I audible? Any one of you, please confirm.
Yes,
Either.
ma'am. Yes,
Okay.
ma'am.
Thank you. Okay. So I'll share my screen. So I think first of all, I should introduce myself again. So my name is Mansi Tripathi. I am TA for this course, Wastewater Treatment and Recycling from IIT Madras. Okay, so this course is offered by IIT Kharagpur, but other IITs are also participating as THF. So I'll share my screen now and we'll solve some assignment questions. There will be some theoretical questions as well as numerical. So there are three numericals. I'll suggest you keep calculators with you. So it would be better if we'll solve it together. Okay. Okay, if there is any background noise or my voice is not, I'll share the screen now. So this is week 2. So we'll be solving. I hope all of you have gone through the weekly lectures. Okay, I think I should switch off one of the equipment. Just a second. Better? Okay, if there is any more noise, please inform me about that or we'll go on. Okay. So I hope all of you have gone through the lectures. Um, Week 2 is more about the quantification of the wastewater that we generate. So when we quantify wastewater, how much wastewater we are generating, there are three things we need to consider. First of all, we should know, see, we will not take care, first of all, we should know that how many people are living in that area, people plus livestock and any institutions are there, all those things we will first of all see. Then we will try to consider what kind of area we are living. For example, if we are checking the population as well as wastewater generated from a well-to-do area, any posh area, so there will be some extra cost of water. Cost of water in the sense means we will use more water. Like if we are living in any posh area, so we will do regular car wash, as well as maybe we are living in a bungalow, so we will have a big lawn outside, so we will keep on watering it, so it will generate more water, more wastewater. So, but if we are living in any smaller area, if we are living in slum, there will be lesser water. Okay, so these things we estimate, we see before finding out how much wastewater is generated. So apart from the quantification, we should know the little background, all these things that what kind of population we are dealing with, what kind of occupation they are in. All these things we need to consider before calculating the wastewater they are generating. And why do we need to calculate how much wastewater is generated? Can anyone answer? In chat box or you can unmute. Okay, so the wastewater we calculate why we are bothered to calculate the amount of wastewater generated. See, if we calculate wastewater generated, first of all, to know the area or the size of treatment plant we will have. If we don't have any such plan about the treatment plant, then we will see wastewater everywhere. all of you must have observed that in rainy season our roads overflow just because we are not maintaining the drainage system properly. We are not maintaining the treatment plants properly. If all these things are maintained, then there won't be any excess drop of rainwater on your roads or in your home in the worst case. So that is why this week 2 is very important. You all should know the quantification. All these things are really important. So we'll see some assignment questions. So this is the question. Question number 1. What are the parameters based on which we can estimate the quantity of municipal wastewater generation? Okay. So these are 4 options. You can answer in the chat box and try to answer the questions. That will be better. So you will know, and I'll tell you answer at the end. And the end means in the end of every question. So it would be better if you will answer these questions. Also, I'll switch on the question answer mode. So if there is any question in between, you can post in the Q&A mode, and I will answer at the end. So I'll switch on Q&A mode. I hope you can see a Q&A is open now. So here you can post your questions. If there is any doubt in the lecture or any general doubt, I'll try to answer them. Uh, Coming towards the doubts, so in the last session, there was a, hello? Uh, Hello. Yeah. In the last session, there was a question that how do we know we should go for centralized treatment plant or decentralized treatment plant based upon the population. So to answer that question, so there is no specific method. People have worked on that area, but it is very empirical. Empirical means is very specific to a area. If we are talking about Delhi, we will divide that into zones. Then only we will study a particular zone, and then only we will know that we should go for centralized or decentralized. So there is no as such general rule, or I couldn't find any general rule. So this question, so all of you are right. So the solution is D. So these are the parameters how by which we can quantify number of inhabitants means the population, per capita water demand, how much water per person is using. So per capita water demand is given on a conservative side, means how much we actually use. The government or the water supply department provides some extra, so that's why we take conservative range. And the wastewater generated is calculated based on the fact that 80% or the 90% goes in waste. So wastewater generated is mostly 0.8 times the water we use, or 0.8 to 0.9 times the water we use. So this ratio or percentage is that 80 or 90%. And these all of the above. So all of you are correct. Coming to question number 2. The flow in sewer line occurring during dry season is referred as dry weather flow. Which of the following parameter does dry weather flow depend upon? Try to answer this question. If you have gone through the lecture, sir has explained this point. Dry weather flow means when dry season means when there is less availability of water. Answer this question in the chat box. Okay, we'll see the answer. So solution is A, quantity of wastewater generated. C, the option B and C, runoff into the sewer. Runoff into the sewer means whatever flow goes inside the sewer. It does not depend upon if the weather is dry or wet. So if there is wet season, whatever the depth of flow we have in sewer, we call it runoff. And if even if it's dry season, so whatever flow we have, we call it runoff. And we water loss through cracks and faulty joints in water supply network. So it means it also does not contribute to the dry season flow. This is the amount of water that go unattended. Means we have no idea how much water is going is lost. So this is unaccounted water. So B and C are not taken care in dry season flow or dry weather flow. So it depends upon the quantity of wastewater generated in that particular season. If there is any doubt, you can ask in between via chat box or you can unmute. Moving towards next question. Which of the following statement is not true regarding separate and combined system? Sir has taught that there are two types of system. One in which a single pipeline is there, in which we put sewage plus rainwater. And in separate system, we have a small for sewage, small pipeline for sewage, and a big pipeline for rainwater. So this is separate system, and this is combined system. Okay, so these are we have to answer what is not true. Separate system is more economical. They are saying this is more economical, or combined system remain underutilized in dry season if there is dry season, because this sewage is this sewer line is quite big. So combined system remains underutilized in that dry season, means there is less flow and money is wasted in dry season. And combined sewer system required one set of sewer pipes. C, I have already answered. Combined has one set of sewer pipes. So what could be the option? A, B, C, D. You guys answer these questions in the chat box. Okay. More answers, please. If you will answer, you will understand better. Okay. So answer to the question is A. Separate system is more economical. C. There are cases in which separate system is more economical, and there are cases in which combined system is more economical. How that works? See, in separate system, we need to dig two holes to make these. Two different diameters of pipelines are required. So the cost of raw material will be more in separate system. Raw material cost will be more in separate system. In combined system, only one pipe is required. So the raw material will be less. But when we dig hole, for this we need to dig big hole. And for this we need to dig two small holes. This is also a factor. Next, what do we have? If, see, uh, during this pipe is big, right? So, when the combined system pipe is quite big, so what happens during the dry season, there will be less flow. So, only this much amount will be utilized. Whole sewage will not be utilized. Only very small amount will be utilized. Small area. So, this area is wasted. So, this statement B is true, that combined system remains underutilized in dry season. Underutilized means it cannot be fully utilized in dry season. And when it's wet season, it will go. It will be full. And what happens in dry season during the separate? In dry season, we will not put any water in this one. We will put water only in this, and it will be fully utilized. And when there is wet season, we will use both the things. So, but still, since the raw material cost is more, two pipes are required, we cannot say that separate system is more economical. We need to check, we need to survey the area for that. That is why option A is not true. Thank you for muting yourself. Yeah. Yes, Hari, you want to say something? Hello, Hari. You can uh, you can ask now or you can type in the chat box. Okay, moving towards next question. Question number 4 is, which among the following is an input component for quantity estimation of sewage? Water discharged from household, used water discharged from various public places, private water supplies to fulfill water demand. So, what all of above all these three, what we will consider to estimate the quantity of wastewater we generate? Try to answer this question. If you want to pursue career in wastewater treatment or any water treatment, you need to know all these things.
Let's look at the answer because few of have answered this question. So solution is D. So to estimate the quantity of wastewater we generate, all these things we need to consider. From the household means from every house, public places like hospitals, schools, offices, all these things, and private water supplies to fulfill water demand. Yes, we need to know private water supplies. Like there are people now, there are people who have borewells in their own house. So they will generate some extra water other than what government supply to our house. So this there will be some extra water generation. So that is why answer is D, all of the above. I hope you understood the question. Moving towards next question. Usually the observed dry weather flow quantities are slightly less than the per capita water consumption due to talking about dry weather flow means when there is no rainy season. Why this water quantity is less than the per capita water consumption? Answer this question please. Yes. Others please try. What this question is saying, forget dry weather flow anytime. when there is no rainwater. So what happens? This is a system. This is a colony, you can say, or a city. We are giving, just imagine 500 million liters per day of water, and how much wastewater is generated? Like four, let's say 475 mld is wastewater is generated. So we can say 10 mld may be used in some purpose. So what about rest of the water? What about rest 15 mld? What is happening to it? So please think and try to answer this question. Okay, let's see the answer. So answer is T. Some water is lost in evaporation. Yeah, there will be some water in the streets and maybe on your rooftop, or you are using water to spray in your garden, so that will be evaporated. If we put water on our gardens, it will go inside the soil, means option B is there. And leakage in pipelines, if there are any pipelines, see, in India, most of the water, like heavy percentage of water goes into leakage. You must have seen there are broken taps on roads, public washrooms, all those things. So these things in India, most of the water goes in leakage. So very less percentage of water is goes to the treatment plants. Most of the water just goes away. So these things needs to be changed. Coming to next question. What is the assumption used for arithmetic increase method? So what is this arithmetic increase method? First of all, it is a method to know the population, to estimate the future population. Okay, so there are, for any population estimation, we go for approximation. We don't know how much exactly population will be there in some near future or any far future. So we keep on approximating. So there are some assumptions. So what that assumption can be? Some people are saying option C. So let's see the answer. So yes, solution is C. What happens when we talk about, uh, you have studied this growth curve. This is population and this is time. Time, years, month, anything. So growth curve goes something like this. So this is divided into various zones. Here, if you have studied differential equation in math, then this dp by dt is slope of graph, or we say rate at which whatever quantity p is represented, p changes. So in this area, dp by dt means rate of population change is proportional to the population. In this area, the rate of population change is constant, and in this area, the rate of population change is decreasing. PS means saturated population. So this area represents arithmetic. If you will remember this graph, then you will be able to answer all the questions correctly related to population. This is incremental increase method we prefer here, and here decreasing rate. If you will remember this graph, then all the questions will be very clear. Any doubt? in this topic? Okay, if any doubt, you can post in the chat box or in Q&A. Moving towards next question. Geometric increase method is more applicable to which cities? See, we have seen here geometric increase method also work. And this incremental increase may work in all the areas. So the question is asking, geometric increase method is applicable to which cities? New cities with unlimited scope of expansion, large and established cities, cities of moderate size and age, very large cities with sufficient demographic data. This is what happens in geometric increase method. Means it is the beginning of S curve. So what happens when a new city is there and we have everything in that city? Means we have good road network. So if there is a good road network, people will come more often. So overall, it's a big city, like it's a new city. Means if we have a airport there, uh, we have railway lines, hospitals, schools, everything is there. So more people from the village and all those areas they will come. Okay, all the people are attracted to these cities because they think there will be more job opportunity. So that is why there is very tremendous increase in population. And in those areas, geometric increase method is employed. Okay, so option will be A, this. As a thumb rule, you can say for very new city, we go for geometric increase. Very old city in which everything is established already means the city which is talking in this area, we go for decreasing rate. Okay, and some moderate city, arithmetic, where the population is almost constant, like no, not constant, like they are increasing in a particular pattern with some constant value they are increasing. So we will go for arithmetic, and this incremental increase method you can use anywhere where you have no information about. Okay, so this you can remember. Coming to next question, what is the assumption used for incremental increase method? Percentage growth is constant, growth rate is progressively increasing or decreasing, population increases at a constant rate, and none of the above. I hope all of you can answer this question. This question is kind of similar to the previous one. Okay. Thank you, Arun. Others? Okay, we'll see the answer. So solution is B. Growth rate is progressively increasing or decreasing. Okay, so here the population is not constant. Like today, if there are 200 people, it's not like tomorrow there will be 400 people, and day after tomorrow will be like 600 people. In this, when the population is increasing with 200 people every day, it's uh, so when the population increases with 200 people every day with any fixed number like population of n plus 1 day divided by population of n day, if it is constant, then it is arithmetic. When it is not constant, when this value keeps on changing, then it is incremental or decreasing rate method. So here the option is B, if that population is increasing or decreasing. The shape of logistic growth curve is, I have just told you this. The shape of logistic growth curve is, answer this question, all of you can answer. I have just showed this. Yes, yes Arun, correct. So the answer is B. The shape of the graph is S, kind of flat S. In some area, if uh, it may be like this also, very steep S, it can be like this in some areas, but in most of the area it's flat because we don't know when the population will be saturated. This happens when in any particular area, like we say, okay, you can come into this area. This area is very good. Just imagine a situation. I am advertising that I am making a new city, and that area is very good. Everything is there. You all can come, and if you will come, I will give you money. So people will come rushing towards it, and then there is a capacity that only 200 people can come or 2000 people can come. So the capacity, the saturation is just say 2000. So I will reduce it. Okay, now no one can come into this area. So in that kind of area, the growth curve will be like this, not very expanded. Here the curve is expanded now from this side to this side. But in that hypothetical situation, it can be very thin. That the saturation, the maximum population will reach very quick. I hope you understood this concept, how this growth curve is made. Okay, coming to next question. What will be the population of the city with an initial population of 45,000? So initial population is 45,000. Growth rate is 15%. Growth rate is growth rate is 15%, means 0.15, and time is 5 years. And they have asked us to use geometric increase method. It means population is increasing very rapid, and geometric increase method they have asked us to use. So this also means that the city is very new. So who can answer this question? This is numerical, all of you can do, and if you will do, you will practice. Very one liner solution, in a line you can give. Okay, let's see the solution, no problem. solution is this 97450. Population increase in 5 years is 1 plus Rg raised to power 5. Initial population is 45,000. This one 1 plus 0.15 raised to power 5. Raised to power 5, why? Because they have asked us to calculate population for the 5 years. And what is this 0.15? 0.15 is the rate of population growth. And so this is the answer we got. One more important thing, what students do as a mistake. Uh, for example, if the population is given like this, for first year it is given 450, for second year 500, third year 750, fourth year 1000, fifth year 1250. Okay, so and we are asked to calculate the population. For example, we got the population as we are asked to calculate the population of 10th year. So we calculate population as 3263. This is just for example, but you won't get full marks for that. Why? As you can see, with these government data or any data, the least count, the last digit was 000. Looking at all these data, it can be seen that maybe the minimum population they can calculate or the minimum population they have rounded off is around 50. Here 450, 500, all in multiples of 50. So if we will give population like this, it won't be good. Okay, so we can give population like 3300. That will be the correct answer. Because we should not estimate less. We can go for 3250 also, but that may decrease the population. We should always go for conservative side. That's why 3300. So please keep this thing in mind. You cannot present your data like this. Presentation is very important when we talk about population data. Okay, India's population is 1.3 like 135, right? 135 crores. So we will never say 135 crores, 23 lakhs, 53,000, like one. We won't say like that. We will say in a big number. So that is how it should work. So this example, here they have mentioned to value for the nearest thousand. But in any theoretical questions in your college or anywhere, if there is any theoretical question, you should mention the data in terms of the least count, depending upon the data. So that thing is very important. Okay, I hope there are no doubts in these. So if there is any doubt, okay, yes. Thank you, thank you. Option D is the correct one. I'll upload the PDF, right? I'll make this correction. Thank you for pointing this out. Okay. Moving towards next question. You understood it, right? How to do these questions. Moving towards next question. This is also numerical. Here multiple populations are given. First of all, what do we see? Everything is in terms of thousand. So whatever answer you will get, you will convert it into thousands, multiple of thousands. So the population growth of old and well-established community. When we talk about old and well-established, so there will be no incremental increase, no geometric increase because city is old. So either if the population, the difference between the population is going down, we will go for decreasing growth method, and if the difference is going up, we will go for arithmetic increase method. So here they have asked about arithmetic increase method. So take some time and try to answer this question. Anyway, I'll give you the answer, but it will be better if you try. You will know where you get doubts, so you will ask. That will be helpful in your examination. Take some time and solve this question. Draw a proper table with the population data, year, population, increase in population, and solve this question. For arithmetic increase population, the formula is Pn is equal to P naught plus n x bar. This is average. This is initial population. N is the year, and Pn the for which the population we want, means we want for P 2020. So try to answer this question. Okay. Any more? All of you agree with this solution? See? Or there are any counter solutions? It seems everyone is agreeing. Or if you are still solving, you need some more time? Yes, no? Okay. We'll see the solution now. The solution is D. So this is how it's done. Check if it's correct or not. I don't know if this is correct. 1990, 2000, 2010 data. Okay. Ravi Teja, you having doubt in any place? You please match with this solution. If there is any doubt, you can ask. Okay. And what if in this question we would have been asked about 2025, then what will be our n? What will be this value? Correct. 1.5. Okay. When there is jump of 1 decade, then value will be 1. When there is jump of 2 decades, value will be 2. And when there is jump of only 1.5 decades, here means 2025, n should be 1.5. Okay. Let's move towards next question. Any doubt? Any doubt, Arun? Okay. Thank you. Let's see next question. So now this is theoretical question. The available sewage treatment capacity in India is approximately. This is kind of general question. All of you should know. We should try to increase this capacity. Answer this question. Next is kind of general knowledge question. So solution is B. Means whatever wastewater we are generating, we are only treating one third of it. Okay, rest of the wastewater we are just directly dumping into our rivers, contaminating the drinking water source, or we are putting them in uh, any low-lying areas like on land itself, contaminating the groundwater that we have below that. So overall, we are contaminating our drinking water sources, and we are saying how we are getting all these diseases. Most of the diseases in this world are waterborne only. And how they are generated? We are putting pathogens, we are putting bad wastewater, untreated wastewater into our rivers, into our groundwater. That is how we are getting all these diseases. So we should take care of all these things. We should do something to increase this number. We should be in this area equal to the total sewage generated. You see, when the country will develop, more wastewater will be generated. Okay, when we are developing nation, when we will develop now, more wastewater will be generated. But the key is that wastewater should be treated. Okay, moving towards next question. The average annual daily flow of a city is 200 LPCD. The maximum daily and maximum hourly flow of the city, assuming maximum daily flow and maximum hourly flow is 2 times and 3 times of annual average daily flow on any day respectively are. Please take care of the units. 200 LPCD means liters per capita, means per person per day. Okay, and all these options here are in meter cube and hour. So convert liters to meter cube and day into hours. Then try to answer this question. Is there anyone who has solved? Okay, we'll see the solution. So the solution is C. Please check if the solution is correct. 200 LPCD means zero point 0.2 meter cube per day divided by 24. See if it's coming 0.0083. So maximum daily flow, they are saying 2 times, and maximum hourly flow 3 times. So 2 times multiplied by this and 3 times multiplied, we will get this. So that is why option C is correct. Check if the solution is correct. So moving towards next question. The accuracy for which of these methods depends upon accuracy of national population estimate. So there are many methods to find out the population of a small area. We refer the national census. So which of these methods work in that area? Because there are very less population data, very less population sources for the small cities, small towns. We have census, population census for whole India most of the time. So what method we use, and it depends upon the accuracy of national population estimate. logistic growth method, ratio, comparative graphical, or master plan method? Thank you, Ravi Teja. Any counter option? Anyone else? Okay, we'll see the solution. So, solution is B. So, like we want to calculate the population of a city, say Salem in Chennai. So, and we have a population census of Tamil Nadu. So, what happens like this we have for 2001. 2001 we have, and we have for 2002 same kind of ratio, 0.01%, 0.02%. This is just hypothetical data. So we want to calculate for 2010. So we will check these estimate. Either we will plot graph, or we will just find out the difference, average, all those things. Then we can calculate for 2021. This is how it should be done. So if the population data for Tamil Nadu is correct, then only the small city population will be correct. So totally, and Tamil Nadu population will be correct only when the population of India is correct. So ultimately, for a small city, it depends upon the state, and state depends upon country. So when this is correct, then only this is correct, then only this is correct. Okay, so this is the ratio method. We find out the ratio between the two population estimate, and that is how we go on. So this is the last question. After that, we'll end, or if there are no doubts. Which of the following methods takes factors such as development and job opportunities, economic factor, and social facilities into consideration? All these things are there. Which of the method will take care of all these things? I have answered this question in the previous slides. I think question number 3 or 4. So let's see the solution. So solution is C, growth composition analysis method. Growth composition analysis method, because see, these methods are based on the previous data, but this method, growth composition and analysis method, this specifically takes care of all these things, these factors. There are many survey analysis which depends upon all these factors, which takes care of all these things. Then only the population is estimated. So this is the new method. Like it's not a numerical method. That's why it's not given in books. So, but you should know that when all these things are taken care of, when these things are considered as some factor like alpha, beta, like these things are given as a factor. When then population is calculated, it's based upon growth composition analysis method. So this is not numerical method. That's why there is no calculation for it. Just factors multiplying by them and doing the calculation. So any doubt? Uh, if you get doubts in the middle of the week, so what you can do, there is a question answer forum in NPTEL. You can post your question there, we'll answer, no problem. And in class, so you can ask, or you can wait till the next session. So I'm assuming there are no doubts. So if there are, you can post there. Okay. So see you all next week. Bye bye. Eighth question. What is the assumption used for incremental increase method? I will post these slides. You will get all these slides. Yeah, the shape of logistic growth curve. You can unmute and say if there is any doubt. Answer is B, S shaped. See, the shape of curve is S. Population versus time. Time in years. Okay, come on. Thank you. See you all next week. I'm closing on this session now.